By now, I've mentioned a couple of times that you need some sort of relay node once the distance of a point-to-point quantum link exceeds roughly 100 kilometers. And there are several options for implementing these relay nodes. In current generation quantum key distribution networks, so-called trusted relay nodes are used. The way that they work is that they first establish a point-to-point encryption key on each of these point-to-point links. And then the end-to-end encryption key is essentially forwarded hop by hop through this series of encrypted point-to-point links. I'm oversimplifying a little bit, but that's essentially what happens. As you can see in the top row of this slide, this has an important disadvantage. And that disadvantage is that the end-to-end key is exposed in the clear inside each of these trusted relay nodes. So the name trusted relay node is actually a little bit misleading. It's not called a trusted relay node because the node is trustworthy. It's called a trusted relay node because you have to trust that node not to leak the exposed key. This need for trusted relay nodes in QKD networks is one of the most important criticisms on the current first generation of quantum key distribution networks. A more secure, a better method is to use quantum repeaters instead of trusted relay nodes, which is shown in the second row of this slide. Quantum repeaters offer two important benefits. The first benefit is that the keys are not exposed at the quantum repeaters. The second benefit is that the quantum network, which is built out of quantum repeaters, is what we refer to as a universal general-purpose quantum network. It can be used not only for quantum secure communications, but also for other applications such as clustered and distributed quantum computing or sensing. You can think of the current first generation of QKD networks as being similar to the telephone networks of the 1980s, in the sense that they can only run one single application, namely telephony. And quantum repeater-based quantum networks are more like the internet of today in the sense that they can run multiple applications. The challenge with quantum repeaters, however, is that they're an emerging technology. The components that are needed for to build quantum repeaters, things like quantum memories, are only just now becoming commercially available. But we expect that quantum repeaters will become a viable option to replace trusted relay nodes in the next few years. Finally, for intercontinental distance, there's the option to use satellites and ground stations connected by free space lasers. Because the loss in vacuum of space is much lower than the loss in fiber, these satellite-based connections can cover very large distances up to several thousand kilometers. The downside, obviously, is that satellites and ground stations are very expensive to deploy.